Hello, hello. This will be my flight to Minmus. I have landed on Minmus about 2 times before. This is my work in progress to get to Duna, but I'm not going to go ahead and use that because it's a little heavier than what is necessary to get to Minmus and back. So I'm just going to go ahead and load up the prior model. It's a lot lighter, doesn't have nearly as much weight attached to it, which makes it a little bit more manageable to navigate inside the atmosphere. So we're going to go ahead and launch that. There we are. And cool. There's the rocket. So basically what I've got going on here is I have 8 liquid fuel engines with oxidizer attached to them, and 4 solid fuel rockets attached to each of the 8 rocket engines, which makes a grand total of 32 solid fuel rocket engines that propel this thing. I'm going to go ahead and turn on SAS and RCS. Does have RCS right there. Basically what this ship is designed to do is just fly to Minmus, collect a shitload of research points, and then head straight back. So you can actually push space before you get the throttle all the way up, because those solid fuels are going to burn for a while. As you'll notice, the velocity is actually increasing quite quickly. So that's why this vessel thrives really well on getting to Minmus, because it gets out of the atmosphere very quickly. Then you end up with quite a bit of fuel left over to get you over to Minmus and back. So I'm going to start tilting early to the 90 degree. As you can tell, it's not going to be moving much, but it'll still be moving. Basically what I'm just trying to do is I'm just trying to catalyze that orbit already, without any interference. Drop those as quickly as possible. No damage, that's a plus. So now, as you can gather, it's going to be a lot easier to navigate with this thing, because it's lost all that weight. So we're just going to immediately drop it down to 90 by 90. We're heading 093 rather. Closer to 090 is more preferable. So like right there would be nice. And once you break 25, you're probably going to want to drop down to right about there. First engine's out of fuel, drop that. And we can start observing this and adjusting accordingly. So we're already over halfway to our optimum orbit. And keep in mind, there will never be an optimum orbit in my videos. I'm not perfect at making 100 periapsis, 100 apoapsis. So just brought it down to 90 degrees, absolute 0. And that should slow our ascent to the apoapsis to a manageable rate. I'll drop below every now and then just to kind of slow that down even further. Gotta jump out of the map view every now and then to drop the empty engines. And we can actually probably throttle it down from here. Just play with the throttle as you feel necessary. We're trying to conserve fuel here, so. Okay, and once you hit that point, it's probably just a good idea to hit 90 flat. And what we're aiming for is just to get the periapsis over 30,000. We're not going to be making a full rotation around the planet, so that's not really a concern. Drop that spare engine. So this is what we have left. We have 3 engines remaining. These 3. And they all have practically a full tank of gas, which will be handy when we're shooting for Minmus. So Minmus is right here. My guess would probably be we're going to have to hit it pretty quick in order to get to it. right about here. It's actually too soon. It can be sometimes helpful if you set that as a target. That's one other thing to keep in mind. Is that we're way below it. Oh. Even though that's over 1 million, that's acceptable for right now. We just want a trajectory where we can actually hit it for the starting shot. Plus it's a little high on the fuel, so let's see if we can adjust that. So now, oh, there we go. That's a little bit better. Okay, so, and it's roughly the same fuel consumption. Get our ship oriented, and we'll speed up time to get things moving along here. Alright, and we're going to do 3/4 burn. Make sure we're doing okay on fuel. I'm going to step it all the way up. Just because I really don't want to miss that node by too much, or it'll throw the whole thing off. Okay, so we actually overshot it just by a little bit. But what we'll do is we'll call it out here once we break from Kerbal, because it'll require less fuel if we do it that way. Okay. Because see, now that minor adjustment, which would probably take about 100 meters per second of adjustment, will now only take about 18. We've got an hour to go, so again, let's time warp it. And keep in mind this adjustment is probably only going to take about a second and a half of burn. Cool. That is close enough. So now we have a Minmus periapsis of that, and we can adjust it further down the line. That's 6 days out. Now that we're a lot closer, we can sort of kill the thrust on this. To where we can actually achieve something pretty close. It is going to be a game of adjustments all the way up there, though. Okay. As a matter of fact, let's see if we can adjust that further back to yield equal results. Perfect. See, adjusting it this far back, we can actually get a better approach. So as long as you fall within about 300,000 meters, you're good, but obviously the closer you get to it, the better you can work with it. 280. So 211 looks like it's about as good as we can get, and that's a 14.1 meters per second burn in 8.5 hours. Let's see here. Can we find the blue dot? Oh, there you are. And this rocket has plenty of RCS, monopropellant, to work you through most sticky situations. The biggest user of RCS for me is taking off out of atmosphere and trying to do those in-atmosphere adjustments. I spend the majority of my time inside this screen when I'm doing flight adjustments and stuff, because you can, as long as you, if you open it up and it looks like this, all you have to do is push this button and you can do adjustments and adjust your throttle. The only thing you can't see is your staging. So, something to keep your mind on. happened there? Okay. Let's see how we're looking on that. Periapsis is still a little lacking. Oh. Alright. There we go. Okay, so 251 is still going to be good, even though it's a little bit higher than our original observations. And the whole reason why I did that little adjustment is so I can have a general idea of where I'm going to want to accelerate from. And if it's ever wobbling around like that, all you have to do is increase the speed of time, and it'll steady out immediately so that you have a better idea of where it is. So, see, I'm pretty spot on right there. Cool. Alright. So our periapsis is now that. And we can actually accelerate the rest of the way until we get into the entry. The encounter, rather. Okay, and once we're here, probably going to want to move it over like that, and kill the thrust. Now, I don't set up orbits. They kill fuel, and generally speaking, as long as I don't land anywhere near any of my other flags, I can reap a rather large amount of research. I know that might not sit well with some people, but it works for me. And if it works, if it ain't broke, don't fix it. Check our fuel. We're doing alright. Generally speaking, we should have just a tiny, teeny little bit of fuel left inside of our outer two engines that are attached to the main fuselage by the time we hit the ground. That way we have that extra fuel to depart with. So actually right now, before we do any further acceleration, I'm going to lower my landing gears. Because believe it or not, this is actually pretty easy landing, but since I'm using these external fuel modules to leave the planet with and to make it back to Kerbal, I'm going to land a little bit unorthodox. It's what I call a beached whale landing. You kind of want to keep the acceleration low when you're doing these adjustments. That way, when you're trying to kill the engines, you don't overcorrect by accident. Cool. And I actually intentionally overcorrected a little bit there so we can get a closer entry. Because we don't want to slingshot around. What we want to do is we actually want to start retroing right about here. So at this point, I'm going to start quick saving every landmark or so. And you can see Minmus right there. It's a little deceiving when you see yourself coming up on a planet so fast, so it's a little bit easier if you can start looking right here. Okay, so as you see, I've got one flag right here on the far side, one flag on the top. So if we land for this lake right here, this lake-looking thing, which is what I'll be aiming for, we should be alright. So, what I want to do is So I want to set a marker, kill that acceleration, and just pull this ever so gently down. Minute 30 is plenty. Until we're right about there, because my planned landing is going to be right around here, right in the dead center of the fat part. Okay, since we're so tight on time, let's go ahead and find that node, which is right here. As you notice, the closer we get to it, the more fuel it takes to do even the slightest adjustments, which is why we want to do them all away from Earth and away from any other planets, because it costs the least amount of fuel to do so. When you go into deep space, though, it doesn't really make much difference, because what you would perceive as a minor adjustment actually is a colossal adjustment and takes a large amount of fuel to begin with. Okay. Okay, that should be spot on. And I'm shooting for the right spot. Okay, so I'm going to add a maneuver right there, but I'm not going to do any adjustments, just so I know when I want to start doing my retro. So the first thing we got to do is find our retro line, which is right there. Once we're on top of the retro, we can kind of just prepare ourselves. It does not take a lot of fuel to retro burn into Minmus because the gravity is so inordinately low. Keep in mind the retrograde changes as your critical path changes. So if you're starting to make a curve, your retro is going to change, or if you're accelerating, your retro is going to change. And of course, since we're being slingshot around a planet right now, or a planetoid, retro is going to change. Quick save before we do the retro burn. And let's get started. You want to keep an eye on your map, because you don't want to overshoot the gap. You don't want to lose sight of your spot. Okay, so I'm going to stop the retro right there at the edge. Kill that point. Actually, you can see what looks like the lake right there. We're at 18,000 feet. I'm gonna guess that's 0. That would be my guess. So if we're landing in that lake, it's gonna be about 0 degrees, or 0 feet, or yeah, 0 meters in altitude. Okay, so now that we're guaranteed over the lake, we're going to go ahead and retro some more. This one's going to be a longer one. We don't want to lose sight of landing in the lake, though. So, once you're done, and we don't want to make this take forever either. We are officially over water, which means we can start retroing in a serious way. Notice how even just the most gentle tap starts decelerating pretty quick. So like I said, it really does not take very much to retro burn onto Minmus. Now that we're going pretty slow, look at that slope. We want to try to approach it in an almost vertical angle, so that'll be perfect. And it's going to stop us from accelerating here pretty quick. Keep in mind we are beyond the point of quick saving. If you try to quick save, oh no, guess not. 3,000 meters is beyond the point of quick saving. Something around there. Sorry about that. So, once we get to this point, we're going to go ahead and start waiting for the retro to get pretty close to that. And don't worry if we don't have any fuel left in these outside containers when we're done. It's not a crisis. Okay. We're looking for shadows now. Alrighty, once we hit that point, just lay it over sideways. And this is what I was talking about when I was saying beached whale. You're going to bounce a little bit, make sure you land on the gears. And we have successfully landed. So, what we're going to do, observe the materials bay, keep that data, observe the mysterious goo, keep that data, thermometer, keep the data, do a crew report, transmit that. Okay, have him EVA. Apparently it's not water. Once we're out on the ground, we're going to take an EVA sample, keep that for transmission later, keep this soil sample. He says he sneaks a taste of it and does not taste like minty treats, because I think it looks like a chocolate mint ice cream. Curvature 9 landing. 3. Oops, that's a 3, not a 4. 3. Okie doke. Once we're done, turn on RCS. Very gently lift ourselves back over there. Keep in mind the gravity is so low, it's really easy to overshoot. For your stored data, transmit that, guaranteed, keep that. Do not forget to quick save once you've collected all your samples, because it is very possible to accidentally botch it up. Once you do, just RCS yourself to where your gears are off the ground, and you're good to go. And basically, we're just trying to gain altitude to the point where we can actually see over the mountains. We kind of got to be careful about... Oh, easy there. Okay, jump into your map screen, and this is kind of what you're looking for. It's actually the completely wrong direction. So this is why you want to quick save. So, for the exact same reason... Whoops. My quick save locked up that. Anyways, for the exact same reason that you want to look at your map while you're doing navigation and stuff, you want to keep an eye on your map while you're taking off. And you want to conserve your fuel, or for the exact same reason that you EVA and you don't want to thrust too hard. You really don't want to thrust too hard on leaving the orbit here, because it will kill you. Okay, so we're not actually gaining any altitude. Time to step up. We can actually turn that over a little bit more. Okay, and this should put us back into orbit of Kerbal. I'm going to step that up a little bit. Okay, so what we're looking for is this to break out of orbit of Minmus. Turn into that. And there we go. So Minmus escape, and as you can tell, it'll put us in the orbit of Kerbal at 42 peri and 70 apo. This is the longest part, so we're just going to wait until we're out of the 3,000 mark. Time warp as fast as they're going to let us go out of the 3,000 mark. Be sure to make sure your engines are off, because you're going to need some of that. Not a lot of it, but some of it. Okay, once we've exited the atmosphere officially, we can just accelerate to the point where we exit that. We've entered here. So, trick for getting back to Kerbal without using too much fuel. You do not want to retro immediately. You want to wait until you're at the high point and then retro, because there's less distance here to kill. So right around there, you want to start retroing pretty hard, and ta-da. With 134, you're already at 2 million. Retro a little bit more. Right there, 167, you've got a return trajectory. So, we have 8 days to go. Just going to accelerate that pretty high. You want to be careful about going to the max acceleration because days fly by pretty quick. Once you hit about 2 days, you want to cut it down to the second highest. I'm actually going to kill that completely. Find my point. And then resume it up to the second highest. Till we hit about 2 hours. Okay. And we're going third highest. Then fourth highest until we hit about 2 minutes. And you'll notice how our burn path is exactly lined up with the retro. Okay, make the minor adjustments if you need them. And then we're just going to go ahead and, at this point, it doesn't matter how much fuel we burn, because no matter what, if we overburn, we're just going to hit the Earth again. Kerbal, rather. Okie doke. And now, we just leave it up to acceleration. Again, be careful with your maximum speed for time acceleration. Okay, where's our altitude? We're at 1 million. Looks like we're going to be landing on land. At this point, we want to keep an eye out for altitude, not so much. If you want to, you can. You don't necessarily have to, but you can consume all the rest of your fuel anti-burning, because you're going to be entering the atmosphere at about 3,000 meters per second at this point. Or, alternatively, you can just drop everything and deploy your parachutes, and as soon as you enter the atmosphere, it'll deploy for you. And there's no danger to the ship, because all we're going to be carrying is from the containment field up. I'm going to go ahead and retro just a little bit until we kill this gas tank, and kill thrust, and then deploy parachutes. and I'm going to use this stage. Fuel is out. Kill engines. Drop that. Deploy the chutes, and we can go ahead and accelerate till we hit about 100,000 meters. You want to turn off your SAS and RCS at this point, because if you don't, I mean, your ship's not going to land properly. 100,000 meters, and we just leave it up to God. It'll actually kill our time warp for us. Once it kills your time warp, you don't want to reactivate it, because that's where issues start happening, is when you activate time warp, the 1 through 4s inside the atmosphere or something. And parachute should deploy any moment now. There they go. And you'll notice our velocity kills pretty fast. There we go. And we can actually retract that antenna. So already we've gone from over 2,000 meters per second down to less than 200. And the trick is to this, the parachute should deploy anywhere between 1,000 and 1,500 meters over the surface of whatever you're on top of. Or 1,000 or 500 to 1,000 over the surface of whatever you're landing on. Once they fully deploy, it'll bring you down to a steady velocity, which will take forever to land. With 3 parachutes with this small of a load, it's probably going to be like 4.6 to 6 meters per second. Once they're deployed, you can accelerate just a tiny little bit. Slow it down. There they are.